So, first of all, welcome everybody to this webinar. We are happy to have here Emanuele Campiglio, who will present one of his recent works on capital stranding cascades. Emanuele is assistant professor at Vienna University, where he leads the research unit on climate economics and finance. He's an expert in macroeconomic modeling, financial sustainability, policies towards the addressment of climate-related risks, and the political economy of energy transitions. The seminar is included in the activities of the newly launched European Institute on Economics and the Environment, which is a joint partnership between the CMCC Foundation and the Resources for the Future. This institute has a clear mission. It aims at conducting independent research to help policy decisions on environment, energy, and natural resource issues. Emanuele, you have 30 minutes for presentation, and then you will have a Q&A session. All the participants to the webinar through the GoToWebinar platform can submit questions throughout the talk, but this question will be left for the end of your presentation. And we will collect also some questions from the people in the room. So many thanks for having accepted our invitation. The floor is yours.
Thank you very much. Well, so thank you so much for having me. I'm really glad to be here because I would like also to have your opinions on these recent paper of ours. So the co-authors you see here, Louison, Karen Fourreau, and myself were based at VU, the Vienna University of Economics and Business, and then we have Ellie Dawkins and Eric and Benedict at the Stockholm Environment Institute, and Antoine Godin, who is at the French Development Agency. And this is a new paper. It came out as a working paper a couple of months ago, and it's still in development. So we're really looking forward to have your feedbacks on how this could proceed further. Let me jump immediately into what we want to do. So the main literature that we would like to address is the one on stranded assets. So this idea that due to a transition to a low carbon economic system, certain types of assets might become stranded. That is, they might lose a significant proportion of their value. The literature so far, it's a relatively recent debate, but the literature so far has focused on two types of assets. The first one is fossil reserves. So the most obvious one, the origin of it all. So the physical stuff that needs to remain in the ground if we want to respect the 2 degrees threshold that we set ourselves as a policy goal, or that will anyway have to remain there because of technical developments that make certain types of technologies more convenient. So there's by now a large amount of research being done on this. And the second type of asset that is usually discussed is the immediate consequence from the fossil reserves. That is, these reserves are owned by someone. And if it's a private company, but even if it's a public company, we can expect fossil stranding to lead to certain, to some amount of financial stranding. That is, the market capitalization of the firm will drop. The value of the financial assets issued by the firms will also drop. These assets are owned by someone, and they will have a negative portfolio effect. And given that the financial network is very tightly interconnected, this might create systemic risk, cascade effects. And this is, for instance, the work done by Battiston, together with Irene Monasterolo, who is also at VU in our institute. Armon Rezai, that you had 2 weeks ago, also works along these lines in looking at the financial dimension. This has attracted the attention of many policymakers, especially central banks. This Carney 2015 is this milestone speech that the governor of the Bank of England gave, recognizing, acknowledging that this is something that they want to look at. And 4 years later, now we have a network of central banks and supervisor on greening the financial system. So it's really becoming mainstream. What we argue in this paper is that there's a third type of asset that is likely to be negatively affected in terms of stranding by the transition, and it's also likely to create some systemic effect. And this third type of asset is represented by the stock of physical productive capital. So machinery, buildings, built infrastructure, everything that is considered as capital stock in the production process. In this case, we conceptualize the stranding as a drop in capacity utilization. So the idea is you have a capital stock that has been built, it's ready, it can operate, but it doesn't because of some lack of fossil inputs or excessive prices or alternative technologies that are more convenient. I will make some examples later on. What we would like to do is to have a systemic perspective in this. Let me show you broadly what I mean in a stylized way. So you have the fossil input, right? In this case, coal. And depending on where this is produced, you might also have stranding immediately of physical capital in the extractive sector. But then the input goes into other sectors that have that are often very capital intensive. So the easiest example here is it's a coal plant, right? A coal plant that is there, has been built, has a value, but it's just not used. And if you think about it, this is the case that we're actually witnessing because the UK has just spent one whole week without using coal. Now, what about these coal plants, right? They're there, they're stranded physical capital. So this is likely to have implications for the owners of the coal plants, but it's not only electricity, it's about chemicals, it's about steel, it's about metals, and all the other manufacturing sectors that then provide intermediate inputs to other sectors like construction and transport, information and technology, wholesale and retail trade, and then again to downstream services, education, health, finance, whatever you can think of. So we would like to catch this systemic perspective, right? In a similar way to Battiston and other papers do with the financial network. So the end game here is to have a representation of this part, let's say the production network, and then to link it to the financial network. What the Battiston paper does, for instance, is that they take some sectors here, very upstream sectors, and it does create some cascade effect within the financial network because those assets suddenly drop. What we would like to do is also provide a better perspective of what happens here in the production network so that the financial stranding doesn't have to start from the fossil sector, but it can start from the real estate sector or the transport sector or the chemical sector. So that's, let's say, our objective to contribute to the development of a more reliable and comprehensive assessment of macro financial risks of the low carbon transition. There's not much on this, at least to our knowledge. There's a literature looking at committed cumulative emissions. That is, they look at capital stocks, they calculate embodied emissions, and then they usually end up saying this is incompatible with 2 degrees threshold. So we either go beyond the 2 degrees, or we need to expect some premature decommissioning of some of these capital stock. But it's not clear where, how, in which sectors, to what extent, and so on. We have a couple of examples of papers that try to do something similar to what we have in mind, but usually they look at specific sectors, single sectors usually. While, as I said, what we're interested in is more this systemic perspective. So we relate also to some methodological streams of work. As I will explain, we basically base ourselves on input-output techniques, not the usual Leontief model, but the mirror one, the supply-side version of the Leontief model, which is the Gauche model. I will say a bit more about this in a second. And then what we do is we treat input-output tables, or to be more specific, we treat these new tables that we create of stranding multipliers, we treat them as networks. And there is some literature now, both in economics and in network theory and physics, that try to do something. Well, they basically start from the same conceptual basis. They take this complex web of intermediate exchange and treat it as networks. And we do something similar, then we diverge from them because we have different research purposes. So what do we do in this paper? First of all, we create, as I said, these matrices of stranding multipliers, which would tell us the impact of one sector on the capacity utilization of other sectors. This is a pretty long discussion that we have in the paper. I will kind of go short for reasons of time here. The main results that we obtained there, it's a very rich set of information that we obtained, but essentially for our purposes, what we care about is that mining, which is where fossil fuels are extracted, they do seem to be among the sectors with the highest stranding multipliers on the rest of the economic system. So in a way, it's something that we use to justify the research that we do. The second thing that we do is then we focus on the mining sector and we create new networks, cascade networks, in order to study how exactly the stranding risk would cascade down to the rest of the economy, which sectors are affected and through which channels. And finally, we provide an estimate of the total capital at risk of stranding in different sectors. Oh, sorry. Okay. I hope this is better. Let me know. Right. So this is where you can find our working paper. And for those of you interested in the code, we also have a GitHub repository. So if you want to have a look or change it and contribute to this research, you're more than welcome to have a look. Okay, let me start with more details. So this is a stylized representation of input-output tables. I'm sure that most of you are already familiar with this, but essentially this is the source of all our data. In particular, we concentrate here on the inter-industry matrix so that we have a record of all the monetary exchanges between different sectors for intermediate inputs. And usually, this national accounting data is used from the demand side. So with the Leontief model, one can look at how the changes in demand affect the industrial system. What we argue in this paper is that the transition is not really understandable, or at least to our minds, as a change in demand patterns, because we don't know exactly how demand will change. In some cases, we don't have enough granularity of data to be able to, look at the switch from combustion engine vehicles to electric vehicles. But even if we had, it's not always so clear cut, right? So you might have like sectoral shifts, but the supply side, in another way, it's much easier to understand, right? Because there's one thing that needs to decrease, which is fossil fuels. So we adopt this other model, which is not the Leontief model, but the Gauche model, which is a sort of supply side mirror of the Leontief model that has some limitation. I will discuss what they are in a few minutes and tell you, how to interpret their results. But let's say the Gauche model is how you would usually calculate forward linkages, which is a concept in classical development theory that gives a measure of how relevant an input is for downstream sectors, right? And what we do is we calculate the Gauche matrix, right? Using just matrix algebra, a very simple one, typical of input-output techniques. And then we mix them, we mix these Gauche matrices with capital intensity data. And we obtain these new matrices that we call stranding multiplier matrices, because each element of S can be interpreted as the drop in capacity utilization of one sector as a result of a unitary drop in another sector. When I say unitary drop, I mean unitary drop of primary inputs. That is, you can think of workers, like a unit of workers less going into the mining sector and then producing less mining products, fossil fuels, for instance. And how does this affect the capacity utilization of the manufacturing sector, like coke and refined petroleum products, both directly and indirectly through other manufacturing or other services industries. So that's what we obtain. In reality, the other direction is also valid. That is an increase in fossil inputs, but we just don't want to look at that for the purposes of our paper. So we call this a stranding multiplier matrix. Right, so we do so for 10 countries at the moment. We use Eurostat data for 2010. These are the countries. There are some issues related to how harmonizable the data are and how available, especially on the capital stock data. So one of the questions that we're having, that I'd like to have your opinion, is whether we should switch to other bigger databases like multi-regional input-output databases like Wired. The reason why we went for Eurostat data in the first place is that we think they're more reliable. They're like the primary source or closer to the source. But of course, going to Wired would allow us to have a wider coverage of countries. And in any case, at the moment, we use these two databases from Eurostat. As I said, we consider these two types of capital. Essentially, we consider all capital stocks except two big types, which are dwellings and intangibles. But we have productive infrastructure and machinery and equipment. And then we classify sectors using the NACE methodology. This is a table that represents the level 1 categories. So probably you're all familiar with this. You start with agriculture, the primary sector. For us, B is particularly important because it's the source of the shock. It's mining. And then we have C, manufacturing, D, electricity, and so on towards the downstream sector. Usually we have more disaggregation than this. We usually have 64 sectors, so at the level 2 category, but not for all countries. In any case, I will show you some codes. I will remind you what they are, or please feel free to ask me. Okay, so this is the type of network representation that we're able to obtain with these S matrices. So you see that, so this is Germany, 2010. It represents only the most relevant links, and not all of them, because these matrices are dense, meaning everything is connected to everything. Becomes a bit of a mess to represent them. You see, we have all the sectors from A there to B and all the way to S. And each sector you see has a color. And if you see a link of that color, that is an outward stranding link. So it's a relevant stranding effect from that sector to another sector. In the case of mining, which is there, B, you see there's a relevant stranding link, outward stranding link towards manufacturing, one versus towards D, which is electricity and gas, and the minor one to public administration. Other sectors with high stranding effects are M and N. These are technical, scientific activities and administrative and support activities, but you see how more diversified they are. So the stranding is smaller, but they go to a larger number of sectors. If you see instead a link that enters, so a link of another color, this is an inward stranding link. It means some other sector affecting that sector in creating stranding of physical capital. And very briefly, essentially, here we have two sectors that are very heavily affected, exposed to stranding risk, which are manufacturing and public administration. Even H, transportation and storage is quite affected, it's quite exposed, and also E, which is water and waste management. So you see, we have a lot of information. It's a very rich set of information, which we try to reduce in its complexity by creating these synthetic indices. So essentially, we create we take the column sum and the row sum, we come up with these aggregate stranding effects of the sectors and aggregate exposure to stranding risk. Let me show you some results, some brief results. As I said, I need to go quick on this part because otherwise I won't stay within the 30 minutes. The stranding multipliers, this is across all our country sample. And the sectors that create more stranding in the rest of the economy include these that you see in the screen. So we certainly have B, mining. We have some manufacturing sector. And then we have these M and N, which are, as I said before, technical activities, scientific research, administrative support, and so on. We also find for specific countries particularly relevant sectors in terms of creating stranding, like water and waste management for Sweden and Austria, and transportation and storage for the Czech Republic and Slovakia. But essentially, these need to be intended as sectors that are really relevant in providing downstream sectors with inputs. So they have high forward linkages in general, but they're tilted. So the more capital intensive is the sector that is serviced by these sectors, the higher will be the stranding. Okay, so this concludes the first thing that we do. We identified mining as relevant. So this, in our mind, justifies the prosecution of the research, and we then ask ourselves, what about stranding originating in the mining sector? What happens there? So what we do is that we now concentrate on mining. Let me show you directly the pictures, and then I'll just explain it here. So we create new networks. We have B now as the source of the shock, and then we look at how it affects in terms of stranding the rest of the sectors. And we select the most relevant stranding links, and we create according to some value Q. So we take the top Q percentile of stranding links, and we place them on the first layer. We create a first layer of sectors, and then we repeat the procedure for the sectors in the first layer. We create a second layer, we create a third layer, and so on until we don't have any more sectors. You see that not all sectors are represented here. So these are only the sectors that are affected within this selected network of relevant stranding links originating in a specific point of the network, which is mining. So let me tell you, so this is the United Kingdom. I've put here Sweden, Austria. We have them for all. These are the nicest ones because we have more granular disaggregation of sectors. But in the paper and also at the end of the slides, you have them all. So let me tell you some typical patterns that we observe. As before, there's a lot to be said, right? There's a lot of links that we're still trying to understand what they mean and so on. Let me tell you what are the broad messages that we take out from here. So in the first layer, you typically observe the presence of some sectors. The D sector, probably not surprisingly, electricity and gas, is usually the most affected in terms of stranding. This happens in all countries except Belgium, in which the most affected sector seems to be transportation and storage. D is almost always there, the most relevant, but then you also have other sectors that are typically in the first layer. So they're like immediately strongly affected in terms of stranding. And this includes C24, which is basic metals. We don't have C19 here, but we have it in Sweden. C19 is coke and refined petroleum products. The transportation sectors are often there as well. The H sectors. And let me see if I'm forgetting anything. No, so then you, of course, you see some common patterns, but you also see some peculiarities. So we're in the process of trying to understand each country, how it functions. So you see, for instance, Austria has a relevant stranding link to agriculture, which is not always present in the network at all. So in other countries. And then we observe typical cascades. We basically see certain patterns all over. For instance, in the C19, from the C19 sector, we usually see a stranding link to C20, which is chemicals, and H49, which is land transport and pipelines. We observe from C24, the basic metals, there's almost always a stranding cascade towards C25, which is other metal fabricated products and the production of motor vehicles, which then cascades to the capital stock of G45, which is the trade of motor vehicles. So for instance, you see here, you observe it in Sweden, you observe it in the United Kingdom, it's here. From the D sector, which is the most relevant one in terms of stranding, then it cascades down usually to two sectors. E36, which is water management, and O, which is public administration. This, for instance, you observe this E36 in United Kingdom, but not the public administration one. In Sweden, you observe both E36 and O. And another clustering that we observe is between H sectors, so transportation sectors. When one is affected by stranding, then it seems that it cascades to all other transportation sectors. And then, as I said, we observe certain peculiarities. One thing that is interesting that we were trying to concentrate on recently is these cascades in the United Kingdom. You see, it starts from wholesale trade, and then it creates these two long cascades, one more on the manufacturing sector, one more on the service industry. So this also tells us something about the industrial structure, right? The specialization structure of the economic system. This might sound as a sort of proof of concept of, you know, we can create cool networks and so on. And to some extent it is, but we think that there are some policy implications to be taken out from here as well, right? Because we are all interested in going towards a low carbon economic system. We need to manage it, however, we need to make it as smooth as possible, and identifying the specific sectors that might be affected more than others, and how this would then create cascade effects of stranding in the rest of the economic system is relevant for the policymakers. If you remember also, the idea here is to complement the current research being done in financial networks by offering a production network perspective, which is still absent at the moment. So this, in our mind, in the next step of research, becomes a multi-layer network, a double network at least, where you have the production network and the financial network, and if we are able to connect them in meaningful, reliable ways, then we can have a better assessment of how the transition might play out, right? So we identify scenarios that are disruptive, and then we avoid them because we know them. Last thing that we do, this is essentially just a written version of what I just said for reference in the slide. The last thing that we do is we want to have an idea of how relevant this risk of stranding is. And for this reason, we calculate an absolute amount of capital at risk of stranding. We look at both the mining sector, so this is, let's say, a stranding from the source because there is less production because of decarbonisation. And we look at all the other sectors from a use-driven perspective. So depending on how relevant the fossil input is in the production system, we calculate the stranding accordingly. These results need to be taken with a pinch of salt, I would say, because of some assumptions of the Gauss matrix that we have, including, for instance, a substitutability between input factors. You know, if you think about it, certain sectors, if you just stop using fossil fuels at the moment, almost the entire capital stock might remain stranded. It just doesn't work. We don't catch these complementary effects. We just attribute the stranding to each sector according to the proportion of, let's say, the relevance of fossil inputs into the production technology. So in a way, we're catching sort of lower boundary of the capital risk, of the capital stock at risk of stranding. And it's not something like this is the capital that will become stranded, because this is a static analysis, right? It's based on these input-output tables. But of course, the decarbonization might take a long time to take place, and also there will be reactions of the economic system to this type of. So this is what how we frame it in the paper, is that the current capital stock at risk of stranding, okay, that might become stranded. We complement the Eurostat data with Exaiobase, which is another multi-regional IO database to go beyond the mining classification and have a fossil inputs instead of mining, because of course you have other products, other non-fossil inputs, other non-fossil fuels as products in mining, and we come up with these estimates. So you have all the countries, and then you have total capital at risk of stranding, the absolute amount in million euros, and you have the proportion of the capital stock, of the overall capital stock at risk of stranding. So you see that for instance, the largest economies are the one most affected, most exposed in absolute terms. It's not surprising. So Germany, Italy, France, and especially UK, for a specific reason that I will mention in a second. But then if you look at the proportions, you see a large variability. Certain countries like Belgium, if you see, it's, well, it depends on how much you want to call 0.6 relevant, but it's lower. It's the lower bound of this range. While you have, for instance, Slovakia, which is an outlier at 8%. So 8% of the capital stock is at risk of stranding for one reason or another. And then you have the UK, Czech Republic 3.7, UK 3.6, and then all the others. We also disaggregate according to sectors. So we have mining, manufacturing, and electricity as big whole sectors. So we don't disaggregate into, of course, all the different manufacturing sectors here. And essentially what we find is that, well, starting with mining. Mining is relevant essentially for one country, which is the UK. That has a lot of capital stock in the North Sea, and it's essentially in our country sample the only large producer of fossil fuels. So they have a capital stock, while all the others are mainly importers of fossil fuels. In this case, we concentrate both on the domestically produced fossil fuels, but also on the imported ones. So we're focusing on the products. But when we look at extractive capital stock, then yeah, these are the results. But you see that in proportional terms, anyway, it's pretty relevant for other countries as well. Czech Republic, Greece, because just the mining sector is biased towards fossil fuels rather than something else. While Belgium, that's fine. Belgium is essentially non-exposed. So you see a lot of variability. Also in electricity and gas. Electricity and gas is essentially the most exposed sector overall. In all countries except Belgium, where manufacturing is the most exposed, and the UK, once again, because it has the mining sector. So that's the most exposed sector. But for all the others, it's electricity and gas. And you see the values also change quite dramatically. Belgium seems to be not exposed that much, but all the others, we go as up to 35. 35% is the highest one, UK and Slovakia. The manufacturing sector as well, you see the values there. The range is less volatile, but they still go from 2 to 8%. So as I said, this needs to be taken as a rough ballpark estimate. But what we think tells us, this information tells us, is that there is indeed the possibility that these cascades, this stranding coming from the low carbon transition, might be relevant at a systemic level. Let me conclude by well, this is essentially what we do, right? We accumulate a lot of information on a number of sectors, because these stranding multiplier matrices are not only about mining, they're about all sectors. So this can be used also for other purposes. research purposes. But for our purposes, we show that mining is indeed one of the sectors that is likely to create most stranding in physical capital stocks. We identify certain specific patterns that we see all over in Europe, right, of how this risk cascades down. And we then identify also specific weak links in specific countries. And then we calculate this overall capital stock at risk of stranding to say, look, this is something that you should consider because it is likely to affect a number of sectors in a very relevant way. We would like to continue in this direction. So certain things are relatively straightforward and can be included in this specific paper, like we want to extend the country sample. We want to have a better idea of what are the drivers of these stranding multipliers, so some decomposition analysis. And then in the longer term, we, as I said already multiple times, we would like to link this to the financial network and to into a macro setting, possibly. So these are two different things, but they can actually be considered together in future steps of research. So essentially look at the transition not in a static way, but in a dynamic way, and incorporating also substitution effects and reactions from other sectors, emerging other sectors, and so on. Right. Thank you so much.
Okay, so we can start the Q&A session. And I start with a question that I received from the participants to the webinar. Francesca La Rosa is wondering whether you have considered in your cascades also intra-layer effects, because it seems that the effects are vertical. So she's wondering whether you have also considered intra-layer effects and whether considering these effects might change the implication of your results or affect.
Okay. Shall I just answer, or do you want to?
Yes, we go on question by
one
question
by one.
basis.
That's fine. Yes, we have considered them, and in a previous version of the paper, we also had. So the reality, well, look at Slovakia, for instance, right? As I said, these stranding multipliers matrices, they're dense, meaning it's non-zero. All elements are non-zero, essentially. Everyone exchanges with everyone. So we needed some way to reduce the complexity, to show some relevant stranding links. So at the beginning, we considered different types of networks, visualization, and so on. And at the beginning, yes, we considered also the intra-layer effects and the effects from downstream sectors to upstream sectors. So we had a more complicated picture. The main reason why we opted for this representation now is it's for comprehension, better comprehension, and visual representation of the network. Because of course there might be some very relevant stranding things, but it would make the whole picture more complicated. And in a way, it's like taking a sphere and trying to put it in a two-dimensional plan. We kind of need to lose some complexity. It doesn't change the results though. So the cascades are the same. They come up exactly the same, except that there are more links. In any case, I'm happy to provide these figures if interested. As I said, the code is online, so it's just a matter of changing one little parameter, and one can do it.
Okay, thank you, Emanuele. Are there questions from the room?
Yeah, thanks. Very interesting work. I have two questions and one comment. One is about when you estimate the capital at risk. What is how you implement the total decarbonization? I mean, what is the amount? I mean, how you implement technically total decarbonization, how you, I mean, in the IO database. And second one, did you also consider like combining the networks to a full European network where you also have the trade links directly, or they are like, or you have the sector, each trade of each sector within EU countries, or how is it included? And a comment on the bio database, which I think, yeah, I agree, data is a big issue. But so you also you need the capital and the capacity, right? I mean, so this you won't have there, right? I think, if I'm not mistaken. So I think the real value is here to have the assets. So yeah, unfortunately, it will be difficult to I think. Yeah. So trade, yeah.
Yeah. So sorry, I may miss something. Please feel free to repeat because I needed to adjust. We take each country in itself. We do consider imports, as I said. Well, so it's the Eurostat has a domestic table and a total table. We take the total table, so we have both imports of intermediate inputs and final imports, because we're interested in the product in itself. But this is as much as we do. So we don't have, let's say, a multi-regional perspective. Each country is by itself. Then you asked me how we calculate it. So essentially, we have these two types of calculation for the capital stranding at risk. The first one is the mining sector. The mining sector, we just assume that the whole capital stock goes. So this is a 100% decarbonization scenario. That's why I made the introduction about being at risk, because we don't believe that this will actually be the stranding value. But at the moment, the whole capital in the extractive sector is at risk. And all the other sectors, we basically computed, according to these stranding multipliers, the relevance of the fossil inputs into each sector. And we attributed this proportion to the capital stock. So that's why I said a use-driven. And that's also why, we don't have at the moment any better way to do this. But ideally, we would have to consider also some complementarities. But we would have to look at each sector, how, what are the technical coefficients, which might, we don't know where to get the data, and we don't know whether it's possible. And the third question I'm now missing. Yeah.
Thanks.
Okay.
Oh, thank you.
Other questions from the room? Yes. Come on.
Thanks, Emanuele. Also, work and impressive memory on remembering all the tools.
I have a cheat sheet here. You see, just in case.
So, okay, there is only one way to use this microphone. So, in the last table, you show, for example, this 35% of stranded physical capital in a certain country in electricity gas, right? So how can I relate that number, for example, in terms of power plants that get closed? So I'm not sure I understood how you measure capital, and differently from what I know, like capital in the electricity sector to be, for example, related to kilowatt. So how can you not consider all these aspects in this treatment? Like how do you measure capital?
Mm-hmm.
How do you link it to translate, for example, this number back to something related to power plants close, or like energy power that is otherwise created in other ways?
Yeah. So if I understand correctly the question, essentially what we do is we take Eurostat data as they are. They're in monetary terms, so it doesn't really give us a good representation of the installed capacity in physical terms. It's all monetary. And then we, as I say, we combine, we have all these sectoral capital stocks, we create these new matrices, and essentially these these values would represent the amount of electricity generation plants. It's not only electricity, because D also has all the gas part, but all this capital stock, what is the proportion that would remain idle? So according to these assumptions that I explained, this is the amount of the capital stock that would just be there and not work, even if it could work. That's why, you know, that's what we define as stranding in this context.
Okay, so another couple of comments from the web attendants. Someone is suggesting to consider using the GTAP database to account also for substitution effects and trade. And more in general, there is someone pointing to the fact that in a sense your results might be alarmistic, meaning in all this literature on the transition-related risks, one of the bottom line is if we want to achieve a transition with a strong policy initiative, we have to be careful. There are a lot of risks. I was wondering also, in line with some of the comments received online, what are the policy implications that you might derive from all this nascent literature? And second, also whether you feel it's possible to link your results to certain level of carbon taxation, for example, of certain strengths of policy measures.
Mm-hmm.
So, for example, if we go for a certain aggressive policy intervention, can we link your numbers to the strength of the policy intervention?
Mm-hmm. So GTAP, yes, thank you. That's something that we're considering. Maybe not for this specific step of research, but we would like to. We're considering translating this into a more dynamic CGE type of framework, and that's what we would look at. I don't know how reliable or disaggregated the capital stock data is in GTAP. I'm just not aware of it, but maybe there is. Then the transition risks and alarmistic. Yes, I accept this. Let's say it's not our purpose to, show these big numbers in order to say the transition is extremely risky. And as I said, these are more indicative results. Okay, that's why I put a lot of precaution. These ones, the cascades, these are more reliable ones because they include the results for little shocks, how they propagate. Right? So our purpose is more to identify where are the risks and how they might propagate in the system, rather than give, there's give an estimate of there's a lot of risk. I mean, all these assumptions that I mentioned give us those results. So they seem pretty relevant. It's not our objective also to slow down the transition, but we also have to recognize that this transition to a low carbon economic system and a low carbon society is possibly full of dangers, right? And it requires a deep, historically unprecedented structural change. And so in order to get there, I think we need to understand where this can go wrong, right? And when we identify the weak points and then we come up with policy proposals to address them, also whoever is opposed to the transition might also be convinced that this is the right way to go. Regarding carbon taxation, my answer would be no. There's maybe not much that we can do in this framework. As I said, we are considering moving towards a more dynamic setting, and this might be something that we do there. But yeah, not in this context.
Okay, thank you a lot. I think we can go for the final question. Yes, from the public, Laurent.
Yes, thank you for the presentation. I have just a question about the policy framework, because from my point of view, in fact, the fact that you start from mining, you already imply, for example, a taxation of carbon, for example, because you would have like a policy which is more about regulation, then you would start the tree from coal plant from electric generation. So is there like a kind of already policy framework, in fact, which is underlined by your choice of starting from mining?
The choice of starting by mining is not associated to any specific driver of transition, meaning there are possible drivers, right? One is policy. So you have a carbon taxation that affects certain industries, and then you look how this moves to the rest of the economic system. But there might also be some technical-driven change. So suddenly there's a low carbon technological option that is more convenient, and everybody wants to go there suddenly. And this might also be already the case of coal, although coal also has some policy effects on it. And then there might be other things, right? I don't know. Sudden realizations due to climate change impacts that suddenly become visible to everyone, and it's a push for the transition. The climate strike. So our point in this paper is not to identify these different drivers, but just in a very simple way, if you want, understand how the defossilization, which is something that needs to happen, right? A reduction of these fossil inputs might affect all the rest of the industry. So we don't really differentiate among different policy interventions or policy frameworks, no.
Okay, so many thanks to Emanuele for the seminar. And I just want to recall that all the questions that have been received will be sent to Emanuele, so further interaction possible. And further, that seminar has been recorded and will be available on the CMCC website and also on YouTube. And let me conclude this webinar by introducing you to the forthcoming event, which will be held May 14, and it will be a seminar about il servizio climatico Climb, una piattaforma web per l'analisi e utilizzo multiutente dei dati climatici. Many thanks to everyone for having participated to this webinar, and finally, again, many thanks to Emanuele.